Long March 12, LM-12. The Long March 12, LM-12, or Chang Zheng 12, CZ-12, carrier rocket developed by the Shanghai Academy of Spaceflight Technology, CASC, also known as 8th Academy of China Aerospace Science and Technology Corporation, CSC, is a medium-lift, two-stage liquid oxygen kerosene propellant rocket. LM-12 successfully completed its maiden flight on November 30, 2024, at the Wenchang, Hainan Commercial Space Launch Site, WCSLS. The Long March 12 carrier rocket has a 3.8-meter, 12-foot diameter body, with fairings of standard diameters of 5.2 meters, 17 feet, and 4.2 meters, 13.78 feet. It employs a two-stage configuration. The first stage uses 4 YF-100K liquid oxygen kerosene engines with a thrust of 1,250 kilonewtons, 280,000 pounds force. And the second stage uses 2 YF-115 liquid oxygen kerosene engines with a thrust of 180 kilonewtons, 40,000 pounds force. LM-12's payload capacity to low Earth orbit, LEO, is no less than 12,000 kilograms, 26,000 pounds, and its payload capacity to a 700-kilometer, 430-mile, sun-synchronous orbit, SSO, is no less than 6,000 kilograms, 13,000 pounds. The Long March 12 carrier rocket originated from the Shanghai Academy of Space Technology's bid for a launch vehicle design for China's manned lunar landing mission. This design employed multiple 3.8-meter, 12-foot diameter core stages bundled together, but lost out to the later Long March 10, LM-10. The 8th Academy subsequently developed its single 3.8-meter, 12-foot diameter core stage design independently, securing project approval at the Academy level in May 2020 and naming it the XLV-20 rocket, unnamed launch vehicle, in 2020. According to the initial plan, the new rocket was intended to use a 1 horizontal, 2 vertical launch mode for its maiden flight at an inland China's launch site. However, coordination issues regarding the launch pad remained unresolved. In 2022, driven by the large-scale development of commercial spaceflight in China, the 8th Academy decided to change the launch site to the then newly constructed Wenchang, Hainan Commercial Space Launch Site and adjusted the launch mode from 1 horizontal, 2 vertical to 3 horizontal. In February 2024, the name Long March 12 was publicly revealed for the first time in the Blue Book of China's Aerospace Science and Technology Activities, 2023, released by the China Aerospace Science and Technology Corporation, and its maiden flight was listed as one of the major aerospace engineering missions for 2024. In June of the same year, the Long March 12 Y1 mission rocket passed its factory acceptance review, and in July 2024, it was officially transferred to the Wenchang, Hainan Commercial Space Launch Site. On October 8, 2024, the Long March 12 completed joint training at the Wenchang, Hainan Commercial Space Launch Site. On November 26, 2024, the Long March 12 Y1 mission rocket was successfully transferred from the technical area to the launch area of the Wenchang, Hainan Commercial Space Launch Site. At 22:25 on November 30, 2024, the Long March 12 Y1 mission rocket was launched from Launch Complex 2 of the Wenchang, Hainan Commercial Space Launch Site, successfully sending the satellite it carried into its predetermined orbit, marking a complete success for its maiden flight. As a new type of rocket developed in the 2020s, the Long March 12 adopts a number of new technologies to meet the needs of commercial spaceflight and has achieved new breakthroughs in launch efficiency. The Long March 12 is China's first launch vehicle with a diameter of 3.8 meters for meter class, compared to other members of the Long March series launch vehicles, which use a traditional 3.35 meter, 10.99 foot diameter. The 4 meter, 13-foot diameter body allows for a 30% increase in propellant loading and can accommodate 4 new YF-100K engines with a thrust of 1,250 kilonewtons, 280,000 pounds force, effectively improving the rocket's payload capacity. Compared to the larger 5-meter, 16-foot diameter Long March 5, LM-5, the Long March 12's 3.8-meter, 12-foot diameter body can continue to meet the requirements for rail transport, allowing it to be launched from inland launch sites. The aluminum-lithium alloy used in the second-stage propellant tank of the Long March 12 rocket, along with the composite materials used in the interstage and intertank sections and other load-bearing compartments, marks the first time such materials have been used on a rocket in China. The second-stage propellant tank, in particular, achieved breakthroughs in key technologies such as overall structural optimization design, forming, and welding for the aluminum-lithium alloy. Compared to the second-generation aluminum alloy materials used in typical Long March series launch vehicles, the structural weight is reduced by 10 to 15%, tensile strength is increased by 28%, and yield strength is increased by 50%. This allows the Long March 12 launch vehicle to maintain structural load-bearing capacity while achieving a lighter rocket body, effectively improving its carrying capacity and efficiency. The Long March 12 rocket is the first in China to utilize liquid oxygen-compatible cold helium direct pressurization technology. This involves immersing high-pressure cold helium cylinders in liquid oxygen to maintain helium in an ultra-low temperature environment. Leveraging the high density of helium at low temperatures, this technology achieves a storage capacity 5.6 times that of cylinders at room temperature for the same pressure and volume. This unique technology significantly reduces the number of pressurization cylinders, improves their storage efficiency, further reduces the weight of the pressurization and delivery system, optimizes the rocket's overall assembly layout, and shortens the launch vehicle's assembly cycle. The Long March 12 rocket achieved the first engineering application of containment and release mechanisms in China. After ignition on the launch pad, the launch pad first confines the rocket to prevent liftoff. The engines reach 75% thrust, and the carrier rocket uses a fault diagnosis system to determine if all 4 engines are functioning normally within 0.3 seconds. If the engines are confirmed to be functioning normally, the carrier rocket simultaneously issues 3 commands: detach, release, and reverse. So, detach refers to the detachment of the fuel filler and air conditioning connectors within 0 seconds. Reverse refers to the rapid backward retraction of the boom arms after 0 seconds to create space for liftoff. And release is the containment and release mechanism. After these 3 commands are completed, the engines reach full thrust, and the rocket lifts off from the launch pad. The containment and release mechanism took 4 years to develop. The team responsible for it completed 1,200 reliability tests, plus over 2,000 additional tests across more than 10 other categories, including containment performance tests, release performance tests, high and low temperature tests, and random vibration tests. After the Long March 12 rocket launches, the Intelligent Health Diagnosis System will conduct a real-time physical examination of the rocket, performing onboard monitoring and diagnosis of the collected rocket status information. Once a fault is detected, it can isolate the fault and simultaneously replan the flight mission, generating a new flight trajectory online to ensure the satellite accurately enters its predetermined orbit. The Long March 12 series rockets consist of 3 submodels: Long March 12, Long March 12A, LM-12A, and Long March 12B, LM-12B. The Long March 12 and Long March 12A share a diameter of 3.8 meters, 12 feet. The Long March 12 and Long March 12B both use liquid oxygen kerosene engines. Furthermore, both the Long March 12A and Long March 12B possess partial reusability.